hear me?
Yep, I hear you.
Great. So I'm so glad you're here. I have lecture materials at the front for you. So if you want to go ahead and grab those, they have my notes as well as my slides that are available. I am a Warner grad student who studied the Builder's Brewery in Second Life. And so this presentation is actually part of my thesis that I wanted to share. So considering that I'm going to be defending my thesis in a week and a half, there is an evaluation form at the in that packet. So while you are listening to the presentation, any feedback that you can give me would be greatly appreciated. So in the meantime, let me go ahead and get started with the talk. Also, during my presentation, if you have any questions or comments, please go ahead and type them into chat. I'll try and get to them when I can. So this is one of those talks where I start at the ending, then I work my way around. Between April and December 2017, I conducted a qualitative dissertation study at the Builder's Brewery in Second Life. From this study, I developed a new theory of learning called Interactive Spatial Learning, or ISL, which you see here. Now, this presentation focuses on the grounded theory methodology that I used to derive this new learning theory, with the hopes that you might be able to glean some of the qualitative tools that I used for your own studies. So for today's talk, I'm going to start with the problem, space, and context. Then I'll answer the question, why do we actually need a new theory of learning? Afterward, I'm going to explain my reasons for using qualitative methodology and grounded theory, which is a type of qualitative methodological investigation that was best suited for this study. Afterward, I'll explain my study design, then get into the details of the theory of interactive spatial learning. So hang on, because there's a lot here that I'm going to share with you today. So first, I want to talk about the problem space. Before this study, research has approached online learning spaces through two general perspectives, which I call striated spaces and smooth spaces. Incidentally, the references slides are listed in the bottom of these slides. And those correspond to the note card in the lecture materials. So in general, when we view research from a striated space perspective, we can think of the popular metaphor, cruising the information highway. Information is organized in a system of pathways with a structured flow to deliver instructional content. So think about your typical online class. These designs are meant to optimize the transport of knowledge from point A to point B. In other words, research from striated space perspectives is all about how we can make online instruction better. How do we improve online learning outcomes? On the other hand, smooth space perspectives can be described with the popular metaphor, surfing the net. These environments are viewed as open and fluid spaces where content is decentralized and may come from multiple sources. Smooth spaces focus on knowledge flow across users, activities, and spaces through experiences and participation. Now, unlike striated spaces, studies from smooth spaces study how people participate in a virtual space and what they learn through this participation. These studies are normally situated in informal social spaces like World of Warcraft, Facebook, chat rooms, and of course, Second Life. Now, both perspectives have very different definitions for learning and assumptions for learning. In striated spaces, learning is measured and quantified based on the degree of cognitive change in a student. By cognitive change, I mean how much knowledge someone gains from taking a course or from learning something from a manual, for example. On the other hand, in smooth spaces, learning isn't measured. Instead, it's defined as participation. In other words, we learn in smooth spaces by being certain people who do certain things. The being, doing, and participating is considered as learning. Now, in the literature, you can think of one's perspective as falling on a spectrum between learning that occurs in the head versus learning socially. I would imagine that your own view of learning falls somewhere in the spectrum. The most popular view in the literature is the assumption that learning is about what you know, which is why you assess through tests, but it is also acquired socially, which is why there's so much talk about learning in groups. But is this the only way we can define learning? So here's the problem with taking either learning perspective when we apply it to an online learning setting. The exclusive adoption of a striated or smooth perspective may lead to oversights on learning, such as how features within a particular virtual content trigger certain forms of learning, or what I call contextual triggers, the interdependent regulation of cognitive and non-cognitive learning. For example, understanding how we acquire factual versus tacit knowledge and how they may be interrelated. We also have oversights on the socio-emotional cognitive connections. For example, how does one's emotions or attitudes affect learning outcomes? And then finally, we have oversights regarding learner attributes, which can cause learning differentiation. In other words, when you look at the literature, most of it treats everyone in a classroom as if they have the same similar experiences and backgrounds. But we know, even as learners, that this isn't the case. So there's another problem with these perspectives too. And it's actually a really big problem, which is that these learning theories were derived from face-to-face settings that describe face-to-face learning. But we all know meet-space learning isn't necessarily the same as virtual learning. And there's the problem. When we transplant learning from one setting to another, we bring assumptions to our studies that may not actually be true. So in a study by Means et al., who looked across all kinds of online learning research, they observed that, and I quote, much of the literature on how to implement online or blended learning is based on either interpretations drawn from theories of learning or on common practice rather than empirical evidence. Until now, we have had no learning theories derived empirically from a virtual environment. Of course, this was a challenge I couldn't refuse. We needed a learning theory based on empirical evidence gathered solely from a virtual learning environment. We needed to fill that theoretical gap. So somehow, my thesis research was going to do that work. So first, I needed a research site. And thankfully, Sen Maximus, who is in the audience today, came to my rescue. She's the owner of the Builders Brewery. Now, for those of you who may not be familiar with the Builders Brewery, it's a learning community, a school, and a help group with over 38,000 members during the time of my study. In a survey that I conducted, uh-oh, sorry about that. Oh my, okay. Yes, please go ahead and type in the comments because that makes me aware of when my voice toggles out and if you have any questions or anything. Okay, so where was I? Let's see. So, in the study that I conducted, the Builders Brewery members came from over 21 different countries. 88% of them had some college. 25.85% of them were postgraduates, so they had degrees above 4 years of college. And 67.8% of them were over 45 years of age. So as you can see, the Builders Brewery is a very diverse community. And as a strictly volunteer-based community, the Institute offers free classes on primarily content creation for anyone in Second Life. So I had my site. Now, my guiding research question for this study was, what forms of learning emerged from the practices found at the Builders Brewery? I also needed methodology that was appropriate for being able to answer this, which ultimately intended to help me develop a theory of learning. That's why I turned to qualitative methodology. Qualitative methods can provide insights into data that quantitative methods alone do not show. While qualitative methods are more focused on the validation of theory, quantitative methods are more focused on the validation of theory, qualitative methodology may be used to develop or derive theory, which was what I wanted to do. Oh, it came out. It went out again, didn't it? Okay, sorry. My button keeps coming off and... There we go. Sorry about that. So what I was going to say is that grounded theory methodology constructs theory from an iterative cycle of analysis and data collection. In fact, any use, and in fact, we don't even look at external theory. What we actually do is discourage that until we have the final phase of analysis, because we want to avoid forcing a pre-existing framework on the data itself. So you can actually think of grounded theory as growing theory from data. Thank you, Amari. I'll keep that in mind. So yeah, in case it toggles out. So just let me know if my voice goes out, and I'll try and change that when I can. So now let me talk about the tenets for GT methodology. Grounded theory methodology relies on several basic steps. So first, you need to gather as many different kinds of data as possible. Next, you need to look for patterns in your data through qualitative coding methods. There's different kinds of coding methods to use, and it depends on the different types and kinds of data you've gathered. In the references section, I've included a book by Saldana that explains the different ways to code data, and I'll talk about it here too on how I did it. Afterward, you need to compare codes with the same types of data. So, for instance, comparing interview codes against interview codes, and then you have to compare across different kinds of data. So, interview codes with classroom transcripts to look for patterns. Throughout this process, you use these data to refine and adjust your codes. This process is iterative and repeated until you hit data saturation. Data saturation happens when you no longer find new codes in your data. This sounds very confusing, especially to people who are not familiar with qualitative research, so I'm going to use my own study as an example. Now here's the fun part for me. My total data corpus consisted of over 200 files and over 2,000 pages of data that included survey responses, semi-structured interviews, observations, videos, field notes, chat logs, website information, and virtual artifacts such as build scripts and note cards. These data were collected and analyzed in 3 phases over the course of 7 months. I spent an additional 3 months member checking and verifying my theoretical findings with members at the Builders Brewery. I'm going to briefly talk about 2 key parts about my data collection methods before I talk about the coding during the analysis. So, the first thing I want to talk about is participant observation. Participant observation is one of the mainstays for a qualitative researcher, and it was the primary way I collected data for Phase 1. One of the tenets of participant observation is immersion, which involves extended time in the field trying to understand the environment, the culture, and the interactions between participants, their community, and their environment. It involves observation and participation. Before I researched at the Builders Brewery, I had been a part of the community for 3 years and had even helped co-captain the BB Relay for Life team in 2016. For this study, I spent many hours at the site and attended events, took and taught classes and helped where I could. All the while, I took copious detailed field notes and recordings to attempt to capture and understand what was going on. I also talked to many people to try and gather as many viewpoints and interpretations as I could. So as a participant observer, you try to get involved and be a participant in order to understand meaning through other people's perspectives with the full knowledge that you come into any situation with your own biases. So in order to address these biases and to try and see past them, it's important to talk and gather as many viewpoints from multiple people. It went out again, didn't it? I'm sorry. I was going to say this requires a repositioning of the researcher as a learner, while your participants are the experts in your research site. You're essentially learning from them while trying to understand them and learn from how they came to view things from their perspectives. If you imagine your site as a diamond, the researcher is a jeweler who must consider all facets of the diamond. You may need a different lens to view the gem before you can reach any conclusions. But participant observation is a great way to get rich data from your site. I just want to pause here. Are there any questions at all? No? Great. And again, go ahead and ask away in comments even while I'm talking. So in phase 2, I did interviews and surveys. My interviews and surveys took place in phase 2 after my initial analysis and coding. Here, I used my survey to collect demographics about the Builders Brewery community, and I used both survey and interviews to get answers to some of the research questions that came up during my phase 1 analysis. Data that I gathered from phase 2 helped me extend my codes. The interviews really helped me make connections between codes because I could compare experiences across multiple key informants. I formally interviewed 11 participants. Some of those people are actually in the audience today. These data were coded for patterns in a process I'll briefly describe next. So, initial coding is a common way for qualitative researchers to begin the analysis of their data. To demonstrate initial coding, here's a piece of group chat log from the Builders Brewery. I've anonymized all the names except for Froggy, who is one of my key informants. While collecting data, I also began to initially code my data by hand, as you can see here. In initial coding, you attempt to make meaning to what's being said over the words themselves. So, as you notice in the chat, my codes attempt to explain what each post is trying to do. Initial coding is really messy, but the nice thing about GT methodology is that you have many chances to code and recode your data until you get a good handle for what's going on. In some data sets, I've gone over the coding 6 or 7 times, each passage refining my codes, especially once I compared codes across different sets of data. So here's the same excerpt after several different coding cycles. As you can see, I've now refined my codes into categories. I did this after coding through 100 or so pages of data to get the feel for patterns and what's going on. In fact, every code that I eventually used for my learning theory had to be tied to specific examples that I found in my data. These ties kept me grounded in the data and prevented me from seeing things that weren't actually there. There are programs that help with this coding process. I chose to use Deduce for this project to keep track of my codes as well as my data sets. In addition to finding common patterns in my data, I also had to think about how codes related to each other. I did this using analytic memos, which I wrote almost every day of my study, and diagrams such as this one. I drew a lot of diagrams to test out connections between my data. The process that I'm describing, incidentally, is how GT methodologists develop theory from data. There are several different grounded theory approaches. So for this study, I used a combination of constructivist grounded theory methodology and what's called informed grounded theory methodology by Thornburg. In informed grounded theory methodology, I began to incorporate bits and pieces of extant theory in my findings. Now, the premise behind grounded theory methodology is that anything counts as data, including other theories. As such, as I'm going to quote here, extant theoretical concepts and ideas from literature in the substantive field must have to earn their way into a grounded theory by coding, constant comparison, theoretic sampling, memo writing, and memo sorting. They have to make sense to and fit with data and substantive codes and concepts. So it has to fit. And if they did, I could adjust and incorporate these terms and pieces into my theory. But if they didn't fit, I had to reject the theory in favor of my own findings. So you can actually think of informed grounded theory as a filter from which all data and extant theory must traverse before it can make its way into the theory you construct. It's a filter. Now, my daily memo writing really helped make connections between my codes. Once I developed these connections, I shared my theory with my key informants and other people. I used their suggestions and feedback to further refine my work. I also used an evolving codebook to explain what the codes meant and how they related with other codes. So, before I get into more stuff, are there any questions? Okay. So now we're going to get grounded and dirty, okay? So, for example, a subtheory of interactive spatial learning was derived from the code autonomous learning. I defined that term after I asked people to tell me about a project or process that they underwent to learn something in Second Life. I define autonomous learning as the spontaneous, dynamic, self-directed nature of learning that happens at the Builders Brewery. By comparing codes against everyone's stories and against codes in chat logs and classes, I found that there were 4 components that worked in synergy and were common in everyone's experiences. These 4 things were learning cues, learning goals, recontextualization, and resourcing. I used the term trajectories to describe how these components did not appear in the same order of frequency for everyone. These trajectories describe the unique and individual learning processes that people underwent when learning in an online space. It was always a unique combination of these 4 components. So now I'm going to focus on the code recontextualization, which is, as you saw in the previous slide, one of the components of an autonomous learning trajectory. From my study, I found that learning could be both cognitive and social. In fact, some learning trajectories could be very social, while other learning trajectories were very cognitive, meaning people learned on their own without directly interacting with others. In many cases, the cognitive or social aspects of learning heavily depended upon the person or what they were working on. For example, one of my interviewees, Froggy, was a very social person and learned through taking classes at the Builders Brewery. When she was stuck on a project, she turned to people at the Builders Brewery or to her friends for help. On the other hand, Ronan relied on tutorials and videos to learn meshing on her own. When she was stuck, she would work through her issues to solve them on her own. However, she kept the Builders Brewery group chat window open because she learned by passively listening to group chat. So, taking either a smooth or striated perspective may only give you half the story when it comes to learning. What I found, however, is that there's an alternative to defining learning. So based on my data, I define learning as the recontextualization of information into different modalities through interactions. Now, this is a mouthful, but what it means is that we learn when we move or translate information from one form to another. So take, for example, this picture, which is quite appropriate for today, which shows one of Blue Heron's self-directed learning workshops, which I talked about in yesterday's lecture. In this class, students choose among a list of projects that they would like to make. Once they've made their choice, Blue gives the student a folder which contains the building materials along with instructions written on a note card for how to make the item. Students are learning when they take Blue's instructions and make the item in Second Life on their build platforms. Hence, information from one modality, the note card, is translated by the student into another modality, the project, through the student's interactions with the note card and the SL viewer to construct the item. That is what learning is in the virtual space. Sorry, thanks, Sen. So, if a student gets stuck, they can ask for individualized help from Blue. who can then look at what the student has created and provide the right assistance to them. Notice that this is a prime example for how learning can be both cognitive and social, and that both work together to cause recontextualization to happen. Now, I can say a lot more about recontextualization that happens in interactive spaces, but I'm going to run out of time. So here's the quick version of interactive spatial learning. I'll talk in far more detail about my theory at my dissertation defense, to which you are all invited to attend on the 27th of March at 10:30 a.m. SLT. If you happen to miss this talk, however, I'll be doing it again at the Brewery sometime in April. So keep your eyes peeled for that, okay? So, in the meantime, let's recap. Autonomous learning describes the way people learned at the Brewery, which was spontaneous, self-directed, and independent. ISL is the underlying theory that explains how people learn through recontextualization across interactive spaces. Interactive spaces are where information and knowledge is generated and transformed. They're formed at the intersections between technology mediation, knowledge places, and community-based discourses. Again, learning happens when information is moved into the interactive space, into interactive spaces that cause this information to be recontextualized into different modalities. It's a lot, but let me put this into context. So in the space of a conversation, I draw from my own experiences and knowledge when I talk to people. They, in turn, draw from their own experiences when they talk back. Learning can occur when I have to recontextualize what I'm saying, meaning I'm taking my experience and recontextualizing that information to fit those words into the context of my conversation with other people. They, in turn, are doing the same. They're also taking what I've said and recontextualizing it with their own information. Thus, you can think of an interactive space as a giant mixing bowl where information from lots of people, drawn from lots of different knowledge places, gets stirred up to generate new ideas and concepts. The space of a conversation, therefore, is an interactive space, yet that wouldn't happen here in SL without the technology medium like our SL viewers. So for example, a sandbox, a group chat, or the workspace in a classroom can be considered an interactive space if the learner has an opportunity to recontextualize the information. The space of a conversation, for example, can take place in the space of an IM, move over to a sandbox, and then take on the form of a co-constructed house that two people create. The flow of ideas and recontextualization happen in that conversation, which is an interactive space. The sandbox is an interactive space too. Also notice that learning is no longer limited by what's in the head or interactions between people. As we know, we can learn on our own. However, we do need to interact with the information found in people, in places, in communities, and spaces. Additionally, learning then isn't so much about social as it is about spatial interaction in spaces through recontextualization. It's where it occurs that becomes important. As I mentioned then, a sandbox, a group chat, or the workspace in a classroom can be considered an interactive space. So then what does this imply? So if a student is being lectured to, are they actually learning? And I would argue that it depends. It depends on whether or not that student has opportunities to recontextualize the information that they've received. So while you think on that, in my dissertation, I make the argument that ISL truly does fill the gap between striated and smooth space perspectives. Again, I'm going to see more on that in another talk. Are there any questions right now for me, though? Okay. So you ask, have you explored virtual worlds as a tool to which to make... Yeah, that's actually the what I just presented was what I did in Second Life, because the Builder's Brewery is here actually in Second Life. So the coding and everything that I talked about was my dissertation. So yeah, I do agree though. It is definitely, and I'm definitely interested in collaborations in that case, yes. Other questions? So let's ask, what's the role of scaffolding information in this theory? That's a good question. And I would say right now, how about let me think. Scaffolding happens in community-based discourses. So let me just go back really quick. So if you look here, you'll see 3 constructs that make up ISL. Community-based discourses I didn't go into detail about. However, there's an instructional component to that. And in terms of Shaylee's comment, of Shaylee's question, sorry, I'm trying to type and talk at the same time. What I'm finding is it's the mediation that makes a difference. We move from technology mediation to physical limitations like time, space, accessibility. And I'm working on that one. A lot surprised me, actually, Zinnia. First, I wasn't expecting to redefine learning. But the theories we had didn't fit the data. Now, if you think about how we conceptualize learning now, assess for it, and design it, what's the implication when it's about recontextualization? That's the burning question. Okay, so I'm going to finish the last slides and then we'll come back for questions, okay? Okay, so let me get back. Okay, so for those of you interested in grounded theory methodology, the purpose is really to generate theory. It's an abductive method, meaning that grounded theory methodology uses data to generate explanation, as opposed to deductive, which is about applying a framework to the data. You can think of this as a bottom-up model, as opposed to a top-down model, which means that patterns and ways of thinking come from your data. As such, they may illuminate into new ways of thinking and looking at data that you may not have conceived of before. This methodology is also subject to change. As more data and studies are incorporated into the process, the theory evolves. The methodology isn't about looking for a definitive. Instead, it posits that theory is both hypothetical and pragmatic because all assumptions are viewed with skepticism unless they can be supported by data. Hence, the process may produce a robust theory supported by data if the researcher remains faithful to the process. Oops, sorry. Okay, so I'm going to go to the next one. The other thing that I learned in the early stages of grounded theory methodology is that it's best not to read the literature while you're collecting data because you'll want to make it fit. It's human nature to try and force a theoretical framework onto the data in order to make sense of it. So to keep from doing that, I suggest applying Thornberg's principles to your work. Be skeptical and also continually test your codes, meaning as you look for trends and patterns, look for exceptions, try to break your theory and collect data that may help you do so. This is why I interviewed and surveyed during my second phase of data collection, because I used that information to further develop some of my codes while eliminating others. Thank you, Mal. So what I was about to say is you need a mentor, or you need to find people that have some grounded theory methodology experience. Because there's a lot of studies out there that claim to be grounded theory, but in reality they weren't. Finally, you also need to really trust in the process. I use Sharma's book as my Bible for the grounded theory methodology throughout the study to keep me grounded in my work. However, I had weeks where I felt very lost and very sick of coding. There were times when I wasn't sure if I was going in the right direction. A lot of things changed between my initial models to the final one that I'll be presenting. Those of you that were at my U of R session in October, you'll notice that there's a very different version of this theory now. So as a grounded theorist, I've grown used to that feeling of being lost in the data, but it is by no means a comfortable experience. Again, having a mentor is just very helpful to validate those feelings of frustration that you may feel in a grounded theory framework or methodology study. Now, research doesn't stop with just the formation of theory. In fact, my current work research doesn't stop with just the formation of theory. In fact, my current work has been on investigating how well my theory holds up to face-to-face learning. What I've found is that interactive spatial learning helps me see and explain how learning is different under different contexts. So now that I have my theory, my next step is to test the variables within the theory using quantitative methodologies. For example, if we posit that learning is recontextualization, how does this change the way we quantitatively assess for learning? Sorry, son, I'm trying to talk. Okay. At the same time, I'm revisiting the use of instructional design models and how my new theory can be applied to these models. Thus, oh, good. Okay. Thus, I end my argument that qualitative methodologies, more specifically, grounded theory methodologies, are useful for starting or augmenting a study, and that when used effectively, they complement qualitative research. So GT methodology allows you to boldly go and theorize where no one has gone before. Warp speed aside, this methodology may illuminate into patterns of thinking beyond our current presuppositions and notions. So, thank you so much for coming to my talk. Since I'll be using part of this talk for my thesis defense, I'd appreciate it if you could please give me some feedback. There's a feedback card in the lecture materials. If you could please fill that out and return it to me, it would help me a ton. My contact information is also listed in the lecture card as well as here. So if you like the talk, I invite you to virtually attend my dissertation defense on March 27th at 10:30 ISLT using Zoom. The exact link will be displayed under my profile pics once I've received that from my university's IT department. So thank you again for coming.